I'm Luc, ON7DQ, and behind the camera is Jill, ONL12523. He's the programmer of all the software in our Morse Box project. If you haven't seen the introductory video, go back to the YouTube channel and watch that video first. This video is about the extensions that we made after we made the basic project. That is, decoder, the generator, and adding some iambic keying modes. The new firmware includes a few bells and whistles, like 2 different options for a receive decoder, which also decodes the send text in firmware. We have a new way to use the built-in sine wave generator as a test generator. We have selection between 3 iambic keying modes, that means plain iambic and modes A and B. And we have a very easy method to update this firmware into the Arduino with a new program called Xloader. And of course we have also a new version of the Windows control program. Now let's have a look at all of these upgrades to the OST Morse Box. First of all, we have a very simple decoder using a PLL tone decoder integrated circuit, the well-known LM567. It's a small PC board that you have to assemble with through-hole parts, and you can even build it on a piece of perf board. It only contains a few components. Here you can see a picture of the complete decoder. Now this board needs 2 controls. On the Morse box you can see that it has a PLL level control, which sets the input level, and you have the PLL tune control, where you can tune the correct frequency that you want to decode. There is a switch below the decode buttons to select this PLL decoder. And of course we had a push button to put the decoder in the on or off state. Now you can have a problem. Let's say you hold a CW net on the 2-meter band on the local clock frequency, and you expect everyone to use the same side tone. So you can tune to the side tone with the control and leave it at that, and everybody should be decoded. Of course, when someone uses a different side tone, you will have no decoding. In that case, you can select the other decoder option, and that is the bandpass filter decoder, which needs no tuning. It's a bandpass filter which filters 450 Hz to 900 Hz. Any tone between those frequencies will be decoded by the level decoder, which is after the bandpass filter. In this case, the only control you have to set is the level control. So, why 2 decoders? The bandpass filter decoder will be perfect for VHF work where only 1 tone at a time is received. But if you want to receive something from HF, from a receiver, there is an external input which you can select with this switch here to the right, and you select the external signal. This can be connected to an HF receiver, and let's say that you have a receiver with no crystal filters and using sideband bandwidth. Sometimes you can have 2 or even 3 CW signals at the same time. In that case, the PLL decoder might give an advantage, because you can tune to one of those frequencies and the others will not be decoded. In that case, the PLL acts as a narrow band filter. Whatever decoder you select here with this switch, its output will be connected to the Arduino on input pin D2. Now D2 in the original project was the test jumper for the touch paddle. If you short this jumper at startup, you will get some figures on the display which can help troubleshoot the touch paddle if there is a problem. Now this is no problem to connect your decoder there, because if there is no jumper, the input is available for other tasks. So there's no problem. The only thing you can have is that you leave that test jumper connected, well, you remove it, you reset the Arduino, and you're back in business. Now this decoder software, or the firmware, also decodes what you yourself are keying with even a straight key or your paddle. So all input from the keys are decoded and also shown on the screen. Now you may have a problem. What is the text that you send and what is the text that you receive? Therefore, the send text is in lowercase and the receive text is in uppercase. Another problem is that this OLED display is rather small. You have about 3 lines of 12 characters text at one time. Therefore, the text is also sent via the serial port to the computer. If you have connected a Windows computer and running the Windows program, you can read much more text in the serial monitor there. And you can even save the whole QSO or whatever you are receiving into a text file for later analysis. Moreover, the send and receive text is differentiated in the Windows program by using separate colors. So that's much nicer than the text that you see on this small display. Let's give a short demo of our decoders. I will first send something with the straight key. Then I will have FLDG on this laptop send some text, and we will decode it with first the PLL decoder, and halfway I will switch to the bandpass filter decoder. Both decoders have been adjusted on beforehand. Let's go. Let's have the quick brown fox on FLDG. I will switch to the bandpass filter decoder. So this input was not coming from the VHF transceiver, but I used the external input, which would give the same result as if you were connected to your FM transceiver or receiver and have someone send you some CW code. There is a push button to switch the decoder on or off, but this push button has a third function. The tone which is made for the CW can be used as a tone generator. So pushing this button a few times switches the decoder off and then switches the generator on. This tone can be used to adjust your PLL decoder if you make a loop-through connector at the back, connecting the output to the input at the microphone connector, or you can use it as a test tone for anything in your shack. The frequency can be adjusted with the speed potentiometer. There are two problems with this. With the potentiometer you cannot put all values of frequency, and you can hear that the high tones are attenuated because internally there is a low pass filter. So it may be a limitation. If you have big plans with this generator, you should take the signal before the low pass filter and build your own filter for this signal. If you use the computer, you can set any frequency in a wider range and per hertz, but we will show that in a video about the Windows program. Of course, if you press the button, you can again switch off this generator and get rid of the annoying noise. Now, some people don't like decoders. For those people, we can of course switch off the decoder, but if you switch on the generator and you use this button to switch off the generator, the decoder will go on again. If you don't like that, you can touch the key or paddle, and now the generator is off and the decoder remains also off. Everybody happy. Now what you can see on the outside is that the new firmware also has added the iambic keying modes A and B. So now you have three keying modes that you can select in the Windows program only. That's the plain iambic without dot dash memory, or the iambic modes A or B. And finally, also not visible on the box itself, is that there is a new way to upgrade the firmware, which is very easy with a program called Xloader. All you need is a hex file and that program, and in a few seconds really you can upgrade your firmware without using the Arduino IDE. There's only one instance where you might need the Arduino IDE, and it is if you want to program your call sign. When starting up the box, I will reset the box here, and you will see that my call sign comes on the screen. This has to be added in the Arduino source code and recompiled and then put into the Arduino. If you don't know how this goes, ask a friend who knows how to program an Arduino. Should not be too difficult. Well, that's about all about the extensions of our basic project. So now we have a Morse box with decoder, with generator, iambic keying modes, and a new way to program it. We hope you like it and enjoy the OST Morse Box 73